we will show you our circus. It's a clock circus. Let's go. Morning, sirs. I am Đức Mạnh, and today our group will present the electronic clock circus based on the synchronous culture circus. And this is our members. First of all, I will talk about the introduction. As you can see, the synchronous counter as opposed to an asynchronous counter is a counter in which the output bit stream stays simultaneously without ripples. The clock input of all the individual flip-flops within the counter are all clocked together at the same time by the same clock signal. The external clock signal is connected to the clock input of every individual flip-flop within the counter so that all of the flip-flops are clocked together simultaneously in a parallel at the same time, giving a fixed time relationship. Next, I will talk about the working principle of the IC 555. As you can see, a stable multivibrator is also called as free-running multivibrator. It has no stable state and continuously switch between the two states without application of any external trigger. The IC 555 can be made to work as an stable multivibrator with the adjunction of three external components: two resistors, R1 and R2, and a capacitor C. The schematic of the IC 555 as an stable multivibrator along with the two external components is shown below in the picture. And in the picture, the pin 2 and 6 are connected, and hence there is no need for an external trigger pulse. It will self-trigger and act as a free-running multivibrator. The rest of the connection are as following. Pin A is connected to supply voltage VCC. Pin 3 is the output terminal, and hence the output is available as this pin. The pin 4 is the external reset pin. A momentary slow on this pin will reset the timer. Hence, when not used, pin 4 is usually tied to VCC. The control voltage applied at the pin 5 change the threshold voltage level, but for normal use, pin 5 is connected to the ground via a capacitor, usually 0.01 millifarad. So the external noise from the terminal is filtered out. Pin 1 is ground terminal. The timing circuit that determines the volume of the output pulse is made up of R1, R2, and C. Next, Sơn will talk about the next section.
So now I continue our presentation. Now we move to the operation of IC 555. The following schematic depicts the internal circuit of the IC 555 operating at stable mode. When the power supply pin 2 and 6 have the least resistance, thus pin reset of the flip-flop in IC 555 is low and pin set is high. Therefore, the output pin 3 is high and power is low. It makes the discharge transistor off. The capacitor will be charged to two resistors. When the capacitor is charged above 1/3 VCC, pin 2 will pull the comparator to low, and the capacitor continues charging. When the capacitor is charged above 2/3 VCC, pin 6 will activate the comparator 1 to high in order to reset flip-flop. At that time, the output pin 3 is low, and it makes the discharge transistor on and allow the comparator to discharge through it. The voltage across the capacitor drops to 1/3 VCC. The trigger comparator will output 1. This will turn off the discharge transistor and the comparator will start to charge again. So these processes of charging and discharging between 2/3 and 1/3 of the supply voltage will keep running on its own, thus processing a square wave on the IC555 timer output.
Hello, I'm Nghi, and today I would like to talk about the electronic clock using synchronous counter. First, here we have the IC555. As mentioned above, IC555 is used to generate pulse and make the clock run with the actual time. I also use the resistance. Here I use R1 and R2 with the resistance 10K to reduce the time error to a minimum. Next, we have the IC7490. At the counter IC to count up, convert number from 0 to 9 to a binary counted decimal, and use the IC74LS47 to decode and pass the information to the 7-segment lag. Here is the 7-segment lag. About the working principle, the IC 555 here will generate pulse every second. Pass the pulse to the IC 7490. The IC 7490 will count up and convert to the binary number. The IC74LS47 will receive information from the IC, decode and transfer that information to the 7-segment lag. And when the lags run to number 9, from the Q3 port of the IC7490 will give an input signal to the IC below, so that the net lag will start counting. But like that, to let we jump up will count from 0 to 99, but 1 minute is only 60 seconds, so I use an end gate. When the IC7490 below count from 5 to 6, the end gate will take the signal from Q1 and Q2 to move to the next IC 7490 here, to the CKA. From there we have the minute, the same with the minute and hour, and I will run it here. The IC555 will make the pull to the IC here, and it give information to the IC74 LS47, and the IC will decode and give information to the LED. We'll make the LED count. No, make the LED show the number. And when the LED here count to 9, it will give the signal to the next IC below, and the next IC below will count up, and we have the LED here, ISO here. 53 seconds, and here when the LED count to 60, the AND gate will receive information from Q1 and Q2, match the input power to the next IC CKA here, and same at here. The IC here will count up, and 7 segment LED will show the number here. Same as the minute here and the hour here.
Oh, hello, I'm Thế Hùng, and after Nghi has discussed some basic about the design of this clock, now I will talk about more in depth. And first is the design of this triple five circuit. We have to choose the right R1 and R2 resistor so that the frequency will be 1 Hz. And I will use this website, and after some trial, I choose one 10K resistor and one is 10 volt resistor, which is the sum of one 10K resistor and three 220 ohm resistor. And now the frequency is 1.001, which is approximately 1 Hz. Next is this number will must reset at exactly 6, so that the second number can only go from 0 to 60. And to do that, we will use this reset gate. And you can see the R0, the D2 R0 gate will reset the LED when it reach high. So to make it reset at 6, we can use an AND gate here, and because the 6 in BCD is 0, 1, 1, 0, so we connect to the two input up and to the Q1 and Q2 here, and when it's reset, it will match the D2 R0 gate gain high value, and the LED will reset to 0. The same as the minute number, but the hour number it must reset at 24, because the two number is 0, 0, 1, 0, and the 4 number is 0, 1, 0, 0. So we use the Q1 in to connect it to the and Q2 from this IC, and then the output of the AND gate will reach D2 R0 of this IC, and the D2 LED will reset to 0 when it reaches 24. And finally, because the CKA this EK gauge normally at a low value, so we can use a high value input to make it increase the number of the LED. So I use a power source here and a button.
Hello, I'm Thế Hùng, and I will introduce to you the product of our team. And this clock is running using this DC generator that convert the 220 volt AC to the 5 volt DC. This clock is using the one AC 205 for the pull circuit and an AC 740A for the end gate, 6 AC 7490 and 6 AC 7447 for the basic clock circuit. These two buttons here is used for setting the hour number and the minute number. As you can see, the hour number will reset at 24. And the minute number will reset at 60, and also when the minute number reach 60, the hour number will we also have a video to show how the number of minute and hour will go up at a certain time. And now I will set the time of this clock to the real time number and let it run for 24 hours.